Good morning to all of you. So, in the last class, we are dealing about continuous charge distributions. Okay, because first of all, we know that charge is discontinuous in nature. Charge is not continuous in nature. Charge is discontinuous in nature, and we know one formula, that is Q equals to plus minus Ne, to calculate the amount of charge contained in a body. But when we are dealing with macroscopic charges, not microscopic, when we deal about huge number of charges are flowing, in that case we can ignore the quantization of charge and we say that charge is continuous in nature. Okay, so when we deal about macroscopic charges, huge number of charges, in that situations we can ignore the quantization of charge and we say that charge is continuous in nature. Similarly, a dotted line, when viewed from a far away, we see that line is continuous. So in that manner, ଯେତେବେଳେ ଆମେ ଗୋଟେ discontinuous line ଟାକୁ ବହୁତ ଦୂରରୁ ଦେଖିବା ସେଟା ଆମକୁ continuous ଦେଖାଯିବ. So when we deal about macroscopic charges, we consider the charge is continuous in nature, and any value of charge, any number can be considered as the magnitude of charges. Okay, so in that case we see the charge distributions, that we call the charge distributions, and we already know that there are three types of charge distributions. One is your linear or line charge distributions, second is your surface or area charge distributions, and finally volume charge distribution. So we have accordingly three types of charge distributions: linear charge distribution, surface charge distribution, and your volume charge distributions. Okay, so today we discuss detail about the three types of charge distributions. First of all, I am discuss about line or linear charge distributions. Okay, so first you know what is linear charge distribution or line charge distribution. Okay, the first time linear charge distribution विषय रे discussion करिबा. Okay, कौन? Now it is defined as the linear charge distribution is defined as the ratio of small amount of charge in a small element of length. Okay, so it is defined as the small amount of charge. It is defined as the ratio of small amount of charge, small amount of charge in a small element of length, delta q or dq in a small element of length. Suppose mane karantu this is a wire having length capital L, and suppose Q is the amount of charge flowing in this wire. Now if we consider a small length, this is the small length CD having length delta L. Suppose charge is delta Q, then the ratio delta Q by delta L is called linear charge density or line charge distributions. बुझी पाले? तो गोटे तार अछि जहार लेंथ कैपिटल L अछि जोथरे Q अमाउंट रो चार्ज टा फ्लो करूछि। जे तार गोटे छोटिया जगह हम कंसीडर करबा जहार लेंथ हला डेल्टा L वेरी स्मॉल और जोथरे वेरी स्मॉल अमाउंट रो चार्ज फ्लो करबो डेल्टा Q, ताहले हम लिखि परिबा linear charge density by linear charge distribution lambda is equals to, this is the symbol of linear charge distribution, lambda is equals to delta Q by delta L, or you can write dQ by dL. Okay, so implies that you can write charge is equals to lambda into delta L. So these are the formula for linear charge distributions. Okay, or here we can write limit delta L tends to 0, this must be equals to dQ by dL. So implies that charge Q calculated by the formula integration of lambda into dL. Okay, so this is the linear charge distributions. Right? What is linear charge distributions? Now it is defined as the ratio of small amount of charge delta Q in a small element of length delta L, or you can write lambda, the symbol of linear charge distributions, is equals to dQ by dL, or implies that dQ equals to lambda into dL, and implies that Q equals to integration of lambda into dL, and this integration is along the length of the wire. तो आमे कहले गोटे तार रे जहार लेंथ कैपिटल L अछि जोथरे कैपिटल Q अमाउंट रो चार्ज टा फ्लो करूछि, तो तार गोटे छोटिया पार्ट आमे कंसीडर करले जहार लेंथ हला डेल्टा L. सपोज मन करंतो सेतरे डेल्टा Q अमाउंट रो चार्ज फ्लो करूछि, तो आमे लिखि परिबा लैम्बडा इक्वल टू लिमिट डेल्टा L टेंड्स टू 0 डेल्टा Q बाय डेल्टा L और dQ बाय dL, और सेथरे आमे लिखि परिबा dQ इक्वल टू लैम्बडा dL और Q इक्वल्स टू integration along the length lambda into dL. Okay, so hence Coulomb's law in terms of linear charge distribution. यदि हम Coulomb's law रा linear charge distribution रे लिखिबा तले केमति लिखिबो? Okay, hence Coulomb's law in terms of linear charge distribution hence Coulomb's law in terms of linear charge distribution F is equals to केमते लिखिबा 1 by 4 pi E naught 1 by 4 pi E naught integration along the length Q into Q1 hela lambda dl, Q1 hela Q, Q2 hela lambda dl divided by R square. Okay, तो वर्तमान आपण जदी linear charge density को नै Coulomb's law लिखिबे तो सेटा हला F equals to 1 by 4 pi E naught integration along the length Q into lambda dl by R square. कारण Q1 into Q2 आपण कोन लिखोंदी Q1 into Q2 by R square, Q1 हला Q, Q2 हला lambda dl एबे हम देखुथले तेनु एमटी करिके आपण Coulomb's law रा करि परिबे. Next point है SI unit of linear charge density. SI unit of linear charge distribution linear charge distribution SI unit कौन होगा तो एटा कौन कूलम पर मीटर ओके is coulomb meter inverse okay so this is all about linear charge distributions second next we come to surface charge distributions what that is your surface charge distributions okay now see we are going to discuss about surface charge distributions. I am writing the heading that is here surface charge distribution or surface distribution of charge. Okay, now we are going to know what is surface charge distribution. That is your charge divided by area. In a similar manner, since we know that linear charge distribution is charge by length, similarly surface charge distribution is charge divided by area. If we take the ratio of small amount of charge to the small area, that ratio gives us what? That is surface charge distributions. Okay, it is defined as the ratio of the ratio of small amount is defined as the ratio of small amount of charge delta Q to the small area delta L. Okay, and we can write linear charge density sigma is the symbol of linear density of charge. Sigma equals to limit delta L tends to 0 delta S delta Q by delta S is equals to dQ by ds. Okay. From this we can write implies that dQ is equals to sigma into ds implies that Q is how much? Integration along area sigma into ds. This is the formula of surface distribution of charge. Okay, so hence Coulomb's law in terms of surface charge distributions we can write. So how can we write Coulomb's law in terms of surface distribution of charge? Or writing Coulomb's law using surface distribution of charge, we are writing F Coulomb's law. So Coulomb's law in terms of surface distribution of charge surface distribution of charge with we are writing F is equals to 1 by 4 pi E naught surface integration Q into sigma into area divided by r square. Next point, last point is here SI unit of surface charge distribution is coulomb meter to the power -2 coulomb per meter square. So this is all about surface distribution of charge. Okay, any doubt? No. बुझिपारे समस्ते सरफेस चार्ज डिस्ट्रीब्यूशंस. फाइनली लास्ट रहिला वॉल्यूम चार्ज डिस्ट्रीब्यूशंस. ओके, volume charge distribution. Finally, volume charge distribution. That is rho. It is defined similarly. First one is your charge by length, second is your charge by area, third is your charge by volume. Okay, it is defined as the ratio between, it is defined as the ratio between, it is defined as the ratio between small amount of charge, ratio between small amount of charge, ratio between small amount of charge delta Q inside a small volume, inside a small volume. बुझियो तो सहज जिनस अच्छी किसी कष्ट नहीं. डेल्टा V. Okay, that is rho. Rho is the symbol for volume distribution of charge. Is equals to limit delta V tends to 0, delta Q by delta V is equals to dQ by dV. So implies that you can write dQ is equals to rho into dV. So implies that Q must be equals to integration of rho into dV, volume integration. Okay, this is the volume integration, three-dimensional integration. Hence, Coulomb's law in terms of volume distribution of charge that is F is equals to 1 by 4 pi E naught volume integration Q into rho dV divided by r square. Okay. So last point, SI unit of volume distribution of charge is coulomb meter cube, coulomb per meter cube. So with this here charge distributions, continuous charge distribution finished. Okay, next हम डिस्कशन करबा इलेक्ट्रिक फील्ड, जोड़ा हम ऑनलाइन क्लास रे बुझिथिले ठीक है, ता विषय डिस्कशन करबा इलेक्ट्रिक फील्ड. ओके, I think I gave little idea all of you about electric field. Remember, I think. Now my point of discussion is electric field. What? Electric field. Okay. So, what is electric field? It is difficult to understand the force between two charged bodies since there is no physical contact between them. Yes, okay. It is difficult to understand. It is difficult to understand the force between two charged bodies since there is no physical contact between them. एटा हम मूव कहिथिले जे तांका भितर किसी कांटेक्ट नाही बट फोर्स केमिति काम करूछि तो सेटा बुझिबा हमको टिके कष्ट लागुछि तो सेटा हम लिखिले. टू एक्सप्लेन दिस Faraday introduced the concept of field and is modified by Maxwell. To explain this, Faraday introduced the concept of electric field. Concept of electric field and is modified by Maxwell. ये जो हम बुझी पारो नहांती केमिति जे ताका भितर कांटेक्ट नाही फोर्स काम करूची त्याको बुझेबा पय फैराडे कोन करथिले ना इलेक्ट्रिक फील्ड रो इंट्रोड्यूस करिथिले. टू एक्सप्लेन दिस जोड़ा परवर्ती समय रे मैक्सवेल को द्वारा मॉडिफाई हेतिला बुझी पाले. तो हम लिखिले इट इज डिफिकल्ट टू अंडरस्टैंड द फोर्स बिटवीन टू चार्ज बॉडीज सिंस देयर इज नो फिजिकल कांटेक्ट बिटवीन देम. तब लिखिले टू एक्सप्लेन दिस Faraday introduced the concept of field and is modified by Maxwell ताको बुझेबा पई फाराडे फील्ड रो सहाय्य नैथिले तो जोडा को परवर्ती समय मैक्सवेल को द्वारा मॉडिफाई करा जाई थेला ओके नाउ असाइनमेंट क्वेश्चन नंबर 1 2 identical charges Q each are kept at a distance smaller from each other. A third charge small q is placed on the line joining the above two charges. The above two charges, okay, such that all the three charges are in equilibrium, such that all the three charges are in equilibrium what is the magnitude sign position of charge 2 where is the magnitude comma sign comma position of charge 2. Okay. And last question is question number 2. 2 point charges class phi and class E are fixed at distance small a apart where should a third point charge Q be placed on the line joining the two charges so that it may be equilibrium so that it may be in equilibrium. The question thila ଏମିତି प्रथम क्वेश्चन है two identical charges capital Q each are kept at a distance small r from each other. The third charge small q is placed on the line joining the above two charges such that all the three charges are in equilibrium. What is the magnitude, sign, position of second charge? The number question thila 2 point charges plus 4e and plus e are fixed at distance small a apart. Where should a third point charge small q placed on the line joining the two charges so that it may be in equilibrium? Okay, thank you all.